Hello friends, today we'll be solving a problem related to electrical machine, and this problem is related to induction motor. And the problem is a 4-pole 50 Hz 3-phase induction machine or motor is running at full load and develops a useful torque of 200 Newton meter, and the rotor frequency is 2 Hz. Then he's asking us to find the efficiency of the motor, and he is asking us to neglect the frictional losses. Okay, so what we can do and how can we proceed for this problem? So we know that efficiency is output power over input power. Okay, input power. So if we are able to calculate both of them, we'll take the ratio and we can get the efficiency. Okay, so first of all, let's calculate the slip. Okay, so slip is, say, S. So S into F stator is equal to F rotor. Okay, so stator flux frequency is 50 Hertz. Okay, and the rotor is given to us as 2 Hertz. So the slip is 2 by 50, and that is equal to, if you calculate it, it comes out to be 0.04. Okay, so this is our slip. Okay, the value of the slip. Now once we calculate the value of the slip, we can calculate the speed of the rotor. So first calculate the synchronous speed. Okay, synchronous speed will be given as ns is equal to 120 into f, which is 50, by p. P is 4. Okay, so this is 1500 rpm. So now we have the rotor, we have the synchronous speed. We can calculate the rotor speed nr as 1 minus s into ns. Okay, so this is our rotor speed. Okay, let's not calculate it and let's see whether we can just solve it that way. So this is, if one equation we put it as 1. Now our output will be nr into our torque developed, useful torque, let's say tau u. So nr into tau u is 200 Newton meter. Okay, so now we have our output power. Okay, so let us write it separately. Our output power is 200 into nr. Now you can clearly see that the frictional losses are neglected, so developed torque is same as the useful torque. Okay, developed torque is same as useful torque, full torque. Okay, so that is also 200 Newton meter. Okay, so once we have this developed torque and we multiply it with synchronous speed, then what we get is, we get our air gap power. So air gap power is equal to developed torque, okay, into synchronous speed, which is ns. Okay, now since nothing is provided, no information is provided about the stator, we can neglect the stator losses. Then this becomes our input power, the air gap power. So this is our input power. Okay, input power. Okay, if some information was provided about the stator losses, then we would have considered those also and would have added that. Okay, we would have added it here. Okay, we would have added it here with 200 ns. But now we know that this is our input power and also output power is with us. So what we can do is, we can simply take the ratio. Okay, so efficiency will be output over input. Okay, the output is 200 into nr over input is 200 into ns. So you can see here that a very nice relationship is developed. It is, efficiency is nr over ns, so which is nr is 1 minus s into ns over ns. Okay, now see, it is 1 minus s. So what we are actually getting now is eta is equal to 1 minus s, which is 1 minus the s that we calculated was 0.04. So we get 0.96. Okay, if we subtract it with 1, then eta is equal to 96% if we do it in percentage. So this is how you can proceed with the problems related to the efficiency of induction machine. Okay, so thanks for watching.